Okay, so I'm trying to get set up. I have no microphone here that will make sure that I sound louder than I actually do. The only reason that I have this here is that I'm taping my own voice so that if I am away from the laptop, there is a chance that you can still hear afterwards in the screencast also what I said. So we'll see how that goes. Just two things to do for today. The last little bit of analysis of variance that we didn't reach the previous lecture. And after that, I'll go through an exam. The exam is online as well. It's from 2014. And we just go through these separate questions one by one and see if we feel that we can actually answer those. And that should be pretty much it. So this is the last little sliver of analysis of variance. Last time I talked about this as the psychologist's way to do multiple regression, basically. And usually when a psychologist ends up with data, it's because some experiment was run. So the variable of interest is a categorical one, where category number 1 is the control, and category number 2 is, okay, we do something, and category number 3 is we do something else. And perhaps we have 12 of those, and what we're interested in mainly is comparisons between these different categories of that single variable. And there are a couple of ways to do it, and we did it already a couple times. And most of the things that we did was compare just 2 of the categories, 1 with 2 and 1 with 3 and 2 with 3 and so on. And there might be reasons to compare more than one, so 1 and 3 with 2, 4 and 5 or who knows what. And there, contrasts comes in. This is another way to make these different kinds of comparisons between different categories of your variable. Okay, so just as a reminder, this is what we had last time. There was one variable in there that we created based on 10 or so questions about which kinds of things you find okay. So smoking in public and all other stuff that is perhaps a little bit fishy. And there was a categorical variable that was called decision making. This was, you could be one of 5 different categories. Actually not really an experimental manipulation here, but given that this was the only one that I had in the data to play with, I go for this categorical one. And one thing to do would be, well, try that one-way command, because that one-way command will allow that Bonferroni correction and will give you all the comparisons between sets of 2 out of these 5 categories. So this is the first output that you get, just a summary. You see different means here. That in itself is useful to see, because if we have only categorical variables, that's the only thing we have. We have means in different categories. So you do see here that there is 0.34, 33 and 34 over there, and 0.5 and 0.42 over there. So you might think here, just by looking at the means, well, if there is a difference here, then in all likelihood it is between 1, 3 and 4 and 2 and 5. That might be something that you could deduce from this, but you want to know if this is actually what's going on. So this is the rest of the output of the same command. Here you see all the different one-by-one comparisons that you can make, 1 with 2, and with 3, and with 4, and with 5, and so on. And the one with the orange squares around it are the ones that ended up being statistically significant, 0.006 there, 3 and 5. So these differences are significant between 1 and 2, 2 and 3, and 2 and 4, and the rest apparently isn't. Okay, so here we have, controlling for the fact that we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different tests here. So the alpha value is adapted in the Bonferroni way a little bit, but then still we see that these 3 differences emerge and the other ones are not statistically significant. So this is similar to what I've shown before, just we see it now in an example where there are quite a few more comparisons being made than just the 3 I think that we had last time. Okay, now contrast. So we already looked at these and saw that, well, 1, 3 and 4 together, that might be an idea, and 2 and 5 as a group together, that might be an idea. How do we do it? Well, different ways to do it. This is what we could already do with multiple regression. We use separate dummy variables. We use the test command. I'll show you an example of that as well. Or, and this is where it starts to be, let's say, a typical psychology, we use what's called a contrast. And in fact, there are subtle differences between these 3 that we won't go into at this point. But if you do end up in our own master, then Antal Hans will go into that in quite some detail. Okay, so 1 and 3 and 4 on the one hand and 2 and 5 on the other. So, well, we can do that. We create a new variable here called group134. It's equal to 0 by definition. So now we first have a one variable in the data that's 0 everywhere. And now I replace 1, 3, and 4 with 1. Well, in which case, if decision making is equal to 1, or equal to 3, or equal to 4. And just to make sure that there's nothing going wrong here with missing values, I make sure that group 134 is missing if decision making itself is missing. And now I run a standard regression. I take my it's okay variable as the target variable, and I take group 134, which is now just a single dummy, as my predictor. In fact, I could also have used a t-test here. And then you see, well, indeed, is that still working? There is a significant difference between, on the one hand, 1, 3, and 4, and on the other, 2 and 5. So that's one way already to do this. It's a bit of a nuisance because you have to do the, well, I'm running out of steam here. Because you have to do the typing over here, but still, it works, and it's just fine. Let's see, the test command, that's the second one, the second way to do it. So you could have here your analysis of variance, and here I accidentally put the I dot in front of this one, and you don't need this at all. So this is an error. But still, you run the ANOVA command, so you should have typed ANOVA it's okay, and then just decision making, because Stata will understand that decision making is a categorical variable. And then what you do is this, well, you see here, 1 decision making, 3 decision making, and 4, that's the 3 categories that we want to take together. And if we want to compare how the mean across these 3 categories compares to the mean across the other 2, we simply create this, 1 dot decision making plus 3 dot decision making plus 4 dot decision making divided by 3 equals 2 dot decision making plus 5 dot decision making divided by 2. So just comparing the means in these different cells. If you type that test command, you again get output that is similar to what you just typed. So as an extra check of how Stata understood what you were doing, and you get an actual test. And again, we see here that the difference is significant. Yeah.
Is that a typo? The bottom part, 1b dot decision making.
I wouldn't expect a B there. And on the other hand, I think it's unlikely that it is a typo because I think it's a screenshot. So I don't know how it ended up there.
Okay.
I'll have a look. In principle, of course, this is not created by me typing. This is output from Stata, right? So the only reason why there could be a typing error is if I copied this literally, and then, you know, to rearrange it a bit to make it fit to the screen or something. That could have happened, and that there ends a B in there. But I don't know. Think it away, and that is what I would have expected here too. So same thing. And the standard psychologist way to do all this, because any psychologist who would see this would think, what is this? Why don't we use the standard thing to do here? And that is define a contrast. And that goes like this. First, we have our ANOVA command again. ANOVA, it's okay decision making. And you get your output, and you do see here that the variable as a whole does make a difference apparently. And now we define our contrast like this. I have to peek if I have, yeah. Same slide, now this just made a little bit bigger. I know that I want to compare 1, 3, and 4 on the one hand and 2 and 5 on the other. So I need to come up with integer numbers in such a way that they add up to the same number here. 2 plus 2 plus 2 is 6, and minus 3 is minus 6, and that's exactly what I want. And that will tell Stata exactly what we need to test here. This is saying to Stata, okay, take these, 1, 3, and 4, put them together in one category, and compare them with those, minus 3 over there and minus 3 over there. And that gives me the contrast, the difference between these two. The only thing that we need to do ourselves here is figure out what the numbers here are. So if we have 3 versus 2, then we need to put there 2, 2, 2, and 2 minus 3s, or 3 minus 2s and 2 plus 3s, that would have worked as well. And then you will get the same kind of answer again, that 0.0004 that we're exactly looking for here. I cannot peek ahead to the next slide in this setup, so I have to do it like this. Yeah. So here are a couple more examples where using contrast you can compare different sets of categories here. So this is 1 versus 2. We already knew how to do that, so we wouldn't need any contrast there, but we could. 1 there, minus 1 there, and zeros for the rest of the 3. 3 versus 4, that would be a 1 over there, and a minus 1 over there. The one that we saw before here, 1, 3, and 4 versus 2 and 5. 3 2s over there, adding up to 6. 2 minus 3s over there, adding up to minus 6. Or 2 on the one hand versus 1, 3, 4, and 5 taken together. Then we get 4 1s over there and a minus 4 over here. And again, if you would have chosen here a plus 4, that would be fine too, but then you put minus 1s over there. As long as all this adds up to 0, you're perfectly fine. Okay, this can be more convenient, especially if you have way more categories in a variable. Then defining these contrasts is usually relatively easy, and it's also something that all psychologists will understand. And in fact, if you prefer, for whatever reason, to use non-integers, that'll work too. Usually I don't find this easier, but there might be reasons why this is easier for you, then okay, that'll work as well. Yeah. Yeah, that's exactly the thing that I hoped you wouldn't ask. The difference that I talked about before, that I don't want to get into here, is that for most psychological experiments, what you have is different kinds of conditions, and pretty much in each condition you have roughly equal numbers. So there what you do is you have, let's say, 4 conditions, and you have 40 persons in the first category, 40 in the second, 40 in the third, 40 in the fourth, or close to it. And then it doesn't matter so much what you do. You can simply look at, okay, what is the mean in that separate cell, and what is the mean in that other cell, and what is the mean over there, and then compare it. Nothing going wrong there. It would be a little bit different if you would have, let's say, one cell in there where we have 1,000 persons in there. In a psychologist experiment that will never happen, but if you have categorical data it might occur for whatever reason. And then you have to decide, okay, what do you want here? Do you really want to compare the 1,000 taking into account that you had 1,000 there, so that you know that the precision there is way higher? Or do you simply want to compare the means across these 4 conditions? And usually the differences aren't that big because you do not have 1,000. You know, you might have 39, 42, 40, and 38, and then, you know, none of that matters so much. But there are in fact slight differences, and what I'm telling here is take it as observed, where as observed means take into account how many cases you have in each of the cells. But for all practical purposes, if you leave the as observed out here, the answer will be slightly different, but really slightly different. So as long as you have roughly equal numbers per cell, it doesn't matter so much. Okay, what else? Yeah, that's the contrast part. So mainly because we need to be able to talk to psychologists every once in a while. For one reason is, well, we're sort of ending up being half of a psychologist. We need to know that what these people do is use these contrasts quite often. Actually way more often than anything that is resembling multiple regression. So you need to be able to read whenever somebody does something like that. Okay, any questions about this part? Because this is in principle the last thing about analysis of variance that we need. Okay, so this is the whole ANOVA and COVA factorial ANOVA story. So you want to use this when you have an interest in differences between conditions, and that you typically have after you've run an experiment. It is exactly multiple regression, nothing else, and the commands are slightly different, and it's convenient if you know the separate ways to to go about analyzing these kind of things, because in some cases it's easier to run the ANOVA command, and sometimes the multiple regression is better. And indeed, this is weird that none of this is simply all in one command. Psychologists use it, especially that whole contrast thing. If you talk to any kind of other social scientist and start about contrast, it's very likely that they not even know what you mean. And there's quite a few more where these contrasts came from. So I just want to, scratch the surface here and mention the word and make sure that you know that it exists, and we'll do way more of that if you enter the master. Okay, all the standard things you can do. You can add a covariate or an interval scaled variable. You can add another categorical variable or a factor. Nothing different from what we had before. And all that contrast stuff that we now are leaving out, I leave to Antal to talk to you about this in 2 years. Okay, that wraps up the stuff that I want to talk about here. And yeah.
I have a question about when normality is, when you check for normality, basically.
Yeah.
So you run SWIL, you also
Yeah.
have to run SK test.
That depends on the result of the SWILC. If that SWILC test already says, okay, normality is violated, then there's no need to do that anymore, because you know it's violated already. If not, then run the SK test just to be sure.
Okay, and so if it's violated, you can only run the K-Wallace test, right? And nothing else, no test, no one way, no ANOVA.
Yeah, so in the ANOVA set of options, there is nothing you can do. There is one way out, however, because if it's analysis of variance, it must be the same as multiple regression. If I have, let's say, a simple ANOVA, so I have one categorical variable, and I see that normality is violated, well, let's see, what would that mean? The equivalent regression command would be, I have my target y, and I have separate dummies for each and every of the categories that I have -1. Normality being violated, that would mean, okay, I look at my residuals, and the residuals are apparently not normal. And for that, in multiple regression, we actually knew a way out. If we don't have normality for the residual there, then what we could use is robust standard errors. And I'm quite sure that if you would do this in a psychologist's journal, nobody would know that this is actually a decent thing to do, but it is. So running a multiple regression there with separate dummies and then using robust standard errors would actually also be fine. And I think in the exam there might be a case even where this is occurring. Okay, then I went through the screencast from last time just very briefly, and then I realized that at some point I answered another question than that was answered, because I think that in fact you asked, are we going to talk about these scale scores at some point? And I understood something, or I heard something completely different. I'm not sure what I answered, but it was not an answer to the question, because that we did, in fact, right before Christmas. So we have that online already if you missed it. But I just realized as I heard it that I missed that question. Okay, so let's see. What would an exam look like? We have this. Okay, let's first go through what it looks like as you will see it. You get a Word file with all the assignments in there. In the beginning, it might look, this is one from 2014, so yours will be slightly different because we now have a different first page that is standard across all exams, I think, so it may look a little bit different visually, but the messages are just the same. So it says here what you're allowed to do. It also says that you are supposed to run this program here. I'll talk about that more next week. So you have to have that on, and here it says something about what you're allowed to do and what you're not allowed to do. And it says here that you're in the end supposed to type your answers in this Word file, making sure that I can understand what you did. You know, I can't say often enough that you have to explain all your answers. So it's not just producing output, because I also need to know that you understand, first of all, why you run this, and also that from the output that you get, that you understand what to look at and what it means. And in this case, yeah, you see for the separate parts the number of points that you can get. And I mentioned in this case that there was a bigger question at the end, so that if for one or the other reason you would prefer to do the bigger question first, then at least you would know about it. Okay, then the only thing you can submit is that single word file and not separate syntax or do files. It's simply too, well, first of all, too time consuming for me. You just say, you know, here's my do file and you figure it out. So you have to cut and paste the stuff from the do file that is of interest to me so that I can understand what it is that you did. And you submit just the Word file and the log file that comes from the exam monitor program. Yeah.
Will we have to meet all the time that is given, or is it enough time to just take a meeting?
It's hard to say. Usually what happens is, quite soon, some people leave. They just wanted to get a flavor of what it looked like and then decided, yeah, indeed, I have no clue what to do, and let's go home. So after the first half hour, we lose a couple. And let's say after the first 1 hour and 15 minutes, a handful who are really fast or know, okay, I know these and you know, the other ones I'm not so sure, but forget it, leave as well. And usually there is quite, yeah, let's say half of the whole group will need the full 3 hours. And that is also dependent on, let me show you the final question here. So this one is the last question in this exam. Come up with a model that explains the target variable as good as you can using all variables in the data. Okay, this is just, go ahead. Yeah, and there, you know, you can take the whole afternoon. That's not a good idea, by the way. And yeah, it's not that obvious when to stop. For the other things, you have a concrete question, how many blah, 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 and your answer is 24, and then, yeah, then you're done. And here, yeah, you have to come up with a model that is a decent representation, and you can check for a long time if it's decent enough. On the other hand, if you have to check for each and every stated command, what was that again? Then you won't be able to make it in time. That won't work. Okay, so in this case, I used the classroom data from that year, which was slightly different actually than the one that we had. And okay, you'll see here that for each and every question, you see the number of points. In general, this is also representing how complicated the question is or how much you need to do. So if you do something that is, let's say, this big for a 5-point question and you get a 25-point question and you do again something that is this big, it's not very likely to be correct. It's also sort of a giveaway of what you should do here. Okay, then I also checked the general grading of this exam, and this was actually a relatively easy one. So the average grade for this was relatively high compared to other ones. Okay, so I put the actual questions in a do file here, so that we don't need to switch back and forth between the two. Let's see, how can we do this easily? Okay, so here we have it. Yeah, here I emphasized that in a minute we'll start producing these different commands. And yeah, the commands by itself need some extra text, usually a little bit of text why you are using this command, and a little bit of text after you've used the command what the conclusion is and how do you get at that conclusion. In the beginning it starts relatively easy. Oh, by the way, I think it's a good idea in general to start with this, clear and set more off. This will allow you to just keep rerunning the whole thing and without having to wait for the scrolling to end. Okay, so this was the classroom data, which is, well, pretty similar to what you had with a couple of exceptions. So first question would be, how many cases are in the data? So what do we do?
Browse.
Yeah, that's one possibility, browse or edit. So this is the data, you browse all the way down and it looks like what? Okay, don't type 110, but type 102, because there are 102 lines of data in here. That would be one way to do it. Browse or typing count might work, or typing summarize will also work. Oh yeah, summarize gives you a long list of output count. Also gives you 102. Actually, this might be a bit misleading, because if we would have had, let's say, 10 empty rows of data at the end, then you of course could argue about how many cases there really are in the data, but then you would have seen 112 here, even though you have 10 cases where there is no data in there. But also here you see, well, for all the different variables, how many observations is 102 most of the time. There are some missings here and there, but 102 is the largest number apparently. So these two things combined give you that 102 number. Okay, so that was easy. How long did participants take to finish the survey on average? Let me make this a bit wider. The variable that's, is called time spent, and what is the median time that people took? Okay, what do we do?
Tabulate time spent, summarize time spent, those details.
Time spent, that was the first one, and?
Summarize time spent, those details.
Okay, sounds like a good idea. Okay, so first that last bit, the median, where do we find this? Exactly, so that's this one over there. And what was the other question actually? Oh, how long on average? Okay, it doesn't hurt to look at this. But it also doesn't help in this case, I think. Gives you a bit of an idea of what's in the data. Oh, by the way, I think in fact that in the instructions of the exam here, there was mentioned don't bother checking for coding errors or other mistakes with the data, because otherwise if you now browse here, you would see that somebody apparently took 0.7 minutes or 1.4 minutes to complete the whole thing, which is way too short. So these two cases you would normally throw out, and in this case I just left them in. So in fact the only thing that we would need here is the actual mean, and that's over there, 26.1. Okay, so let's get rid of the tab. Okay, that's all easy. Does the time that people spent on the survey follow a normal distribution? Well, we know how that works. Well, answer would be no. Normality is rejected quite strongly. Okay, are female students equally likely as male students to like or dislike blues music? And this is actually a question that you didn't have in your survey, I think. There are questions here about music. Which one's blues? That's that one. So let's see what that is. Oh, okay. So there must have been a question in there where there are 5 categories, I guess, ranging from I do not like blues music at all to I totally like blues music. Or there might even have been a category in there, one being blues. What is that? And 2, 3, 4, and 5 saying something about the extent to which you like it. In your case, of course, you do not know, and as I do not know exactly what the categories here were. So normally I would have added a PDF here of the whole questionnaire so that you could see exactly what the questions were like. So at this point, it's not so obvious actually what to do here. Is this an interval variable or not? I think what I meant here, I think actually this first category is, okay, I do not know what blues is. And this is, I do not like it at all. I don't like it. I like it a bit, or I like it a lot. If that is the case, then taking this as an interval scaled variable doesn't help so much, or doesn't make so much sense, I would say. So then, what was it, between males and females? I would simply like to run a tab. Let's do that here. One. So let's see what happens. Okay, so what's next? Yeah, why? Yeah, exactly. We have low cell counts here, 2 and 0. So for that we need a Fisher's exact. So can even ask for both, just to see what would have happened. So here you have it. The chi-squared actually was 0.04, so below 0.05, and the Fisher's exact also 0.035. So in this case it doesn't matter so much. Yeah?
Shouldn't we first sort of disregard the people who don't know what blues music is?
Yeah, the question was a bit weird, I think, to like or dislike. So from this you could assume, also depending on exactly what the question about the music was like, is, oh, okay, then the ones who don't know it simply don't count. You know, if you would say that, would be fine as well, but, you know, then just write it. Okay, so the first category is not obvious because they simply have no clue. And then I compare the other 4 categories with across males and females. In fact, then you might even argue that these 4 categories themselves are sort of interval scaled, and you could try a t-test instead. But if you would have done this here, would have been fine with me as well. So an alternative would be, if that first category would really be that you don't know blues music at all, I disregard that first category and I only compare on the other ones. So one way to, okay, well, might be instructive to show how we would do this. Okay, how do we disregard that first category?
Replace music 1 as point if music 1 is H1.
Yeah, that would work. So the answer would be you replace that first category by missing, and then you do the same thing again. That would work, but I think it is a bit risky. First of all, now that first category is missing for all subsequent analysis that you're going to run. So I normally do not want to mess with the data that I have. So if you want to create a new variable that has a missing there and the same variables, the same values everywhere else, that would be fine. Normally I wouldn't put that in the variable itself. So you could do something like generate blues equal to music 1, and now replace blues is missing if music 1 equal to 1. And now try tab. So that would be just fine, and actually does make a big difference in terms of the answer, because now we get a value over there that is bigger than 0.05. So now we don't see any differences anymore. And let's see. Another way to do the same thing, because for many of these there are different ways to do it, and you know, whatever works is just fine. So the alternative would be to do this immediately with an if statement. Over there. If music 1. That will also work. And I'm simply excluding the music 1 category. And you get exactly the same thing. Yeah?
Do
For what?
If it's a standstill,
Yeah, usually, let's say, loosely speaking, the questions in the beginning are relatively straightforward in the sense that they, there's a quite straightforward question that, where the answer is obvious and complete as soon as you have it. So here, are female students equally like as male students who like or dislike? And then you can just answer, okay, a yes or a no, depending on exactly what you did and what came out. Normally, if I would ask you, okay, here's the data and try to figure out what's going on, then obviously you would be interested here in, if there is a difference, what the size of that difference would be. And you would ask for Kramer's V in this case. And then, yeah, just to show you that, also, perhaps good to know that the this part over there, in fact, this would also work. So the comma in there, in the command, works like a toggle. So the first time Stata sees the comma, it knows, okay, there are options behind the comma. The second time it sees a comma, it toggles back to, this must be part of the actual command. So this is also one way to read tab music1 female if music larger than 1. That will, I think, work as well. Indeed. And normally I find, in fact, this easier because then you see all the conditional stuff way at the back. But, either one will work. Okay, calculate a scale score using all the money-related items, the variables money1 through money14. Is this a good scale? Let's first see what we have. Okay, must have been a 5-point scale. Normally you would check your data just to make sure that you have 1, 2, 3, 4, 5, and only those for each and every one of these separate items. It's also a good idea to, before you do anything, just browse through what the actual questions actually were here. So let's see, what was that? I must admit that I purchased things and, okay, I have to, don't want to mess with the screen again, but you can actually read this if you just pull that to the right a little bit. I find that I show more respect to people with more money than I have. Often try to find out if other people are making more money than I do. I own some things in order to press others, all related to, let's say, your attitude towards money and those who own it. So let's give that a shot. And okay, first question is this a good scale? Well, 0.74, that's not too bad. It's not exactly great, but certainly good enough to continue working with. Also, the other, would be a good thing to do here, even though, if you would say yes because the 0.74 is fine, I think I would just say this is a correct answer. Then still it might be a good idea to look at these actual questions and start to think about what is it measuring actually here, because it does seem to fit on one scale. But if that's the case, then you have to get a feeling for what it is then that is being measured. So in a way, I'm surprised actually that they do fit on a single scale, because when I buy something, I complain about the price I paid. And I find that I show more respect to people with more money than I have. I'm not so sure that all of this is really meaning the same thing, but, well, it does fit on a single scale well. Yeah?
When you use alpha command, you say that with 0.74 then it's okay. What's the scale with alpha command? When do you know if...
Yeah, it's 0 to 1. And yeah, it depends a little bit on which book you read when it starts to be good. But let's say 0.5 or lower is seriously bad. Don't create a new variable from that. 0.6 starts to be shady. You need to have a story to back it up at least a little bit. As of 0.7, we start to be more or less fine. And 0.8 is good. 0.9 is yeah, basically you could have used way less items perhaps. So it's good to use it, but for a survey next time, use less items than that. Okay. So yeah, this is quite a decent scale. If you had to choose one item to exclude from the scale, which one would it be and why? Okay, so, well, the most obvious way to go about it is look at the column on the right over there, because that will tell you if I remove that particular item from the scale, then what will happen to the scale score. So we're looking for numbers here that are larger than 0.7387. Let's see, that one, 0.7507, or that one. I think all the other ones are lower, so let's see, this is 5, yeah, and 9. Now let's have a look at the other ones. Yeah, it doesn't seem to matter so much. So we have a 0.14 here and a 0.16 there. What you do see is that both these numbers are way smaller than the other numbers in the same column, which is suggestive of the fact that they fit relatively poorly. And here as well, but the difference is, well, marginal. So here I would say, well, if I would have to leave out the one, then I would leave out this one. Either 5 or 9, and given that 5 gives at least a little bit more alpha score, then I would lose that one. And the only argument to exclude another one, for instance 9 instead of 5, would be that you look at the questions and get the feeling that, okay, I understand what 9 is and why it fits with the rest, and I don't understand what 5 is, okay, then get rid of 5. And that you could reverse as well. For small differences, even though leaving out the 5 would be better in terms of that alpha value, if you understand better leaving out 9, because that is such a weird question, I don't know if it is, but I hesitate to spend money even, no, it sounds pretty obvious to me, but so if that would be sort of a weird question, that would also be an argument to leave it out. So 5 or 9. Now this one, of course, what is being measured with this scale is nothing that has anything to do with statistics. You simply have to read the actual labels and try to figure out what it is here. And in fact here, it's not so easy to come up with something that is completely consistent with all the different kinds of questions. So what I'm looking for here is first that you try to solve this not through statistics, because it cannot be solved through anything statistical. Then that you actually go through these different things and try to understand or come up with a story that fits for each and every one of these. Yeah, before I forget. Okay guys, here we go again. An incorrect conclusion you could have had here is that apparently in the test sample size is not a question. So there is no need to prepare for any questions about sample size, because you apparently are not there. Well, this is just a coincidence. What I do is I sort of at random choose a couple topics and need to leave a couple out just to make sure that it's doable within 3 hours. So the fact that sample size is not in here means nothing. It could very well be in here in yours. And, you know, perhaps then that whole alpha command is not in there, or an analysis of variance is not in there. So don't take this as an example of what you can skip. Okay, so that was the question about the money items. Next one is the variable no stats. Contains the mean score of the no of 1 to no of 10 items. There are difference between the ones who travel to TUE by bike, that's travel to TUE equal to 2, versus the ones who travel to TUE by train. Travel to TUE is 4, with respect to the no stats score. Okay, so what is that aiming for? Two variables, no stats, and the other one is travel to TUE, where we have to compare two categories. So what's next? Yeah. T-test. Let's have a brief look at no stats. Apparently running from 1 through 5 and decimal values in between as well. So I want to first test for normality here. Swilk, no stats. Travel to 2 and 4, that is. And the whole thing, I'll do that again, but then with the SK test.
Sir, you made a typo, you forgot the app.
Oh, okay. Good point. And I typed the X because this is not a command, and I will make sure here then that Stata will stop at this point. That will give you an error message. If you cannot handle the error message, type exit, and it will also stop, but without the error message. There we go. Okay. So this one is just fine. Normality is not violated there. And this one's also just fine. So we're good to go here for a t-test. Now the only thing to try to figure out here is that, well, we have 2 categories to compare, but they are 2 from a larger set of 5, so that complicates the command a little bit. So what do we do? T-test is allowed here, but we need to make sure that we compare the right categories. Give it a shot.
You can generate a new one that says generate travel, which is 0 if travel to TU is 1. No, sorry.
0 if.
And otherwise, when it's 4, you can have it as 1.
There's 2. Yeah, and what would be the next command?
Replace travel equal to 1, that's fine. If travel to TU is 4.
Okay then.
Then just have it to see.
Yeah, that I think is a good idea to double check to see what happened here. This will give me any missing values as well. Okay, what do we have here? Okay, did it work?
Don't think so. Or it depends on what's in travel to TU.
Yeah, but how? I mean, here we have cross-tabbed travel and travel to TUE.
So in principle, should it work?
That should have, but did it?
Depends. If you could tab travel to TU, then you could see. Yeah, then it did work.
Yeah, the tab wasn't necessary because I mean you have the tab here.
Oh yeah.
Okay, so this working 69 there, 24 there. That's exactly the same as we have over here. Okay. No. And we see here, right in the middle over there, that equality between groups is not rejected, so supported. One other way to do it with slightly different command would be exactly the same here, but do this on the actual travel to TOE variable. And now add an if statement. For. Oh. And you get exactly the same thing. But that'll do it too. Also, there are different ways to create these second variables there. All of these, as long as you get the same kind of output, actually work. Okay, so that one covered. 7. There's a variable in there that's called soccer score. It measures how many quiz answers out of 10 from a soccer quiz a participant answered correctly. Okay, so let's see. Varying from 0, nothing correct, to 10, everything correct. Okay, so there's actually nothing to type over here. And what do we do here? Is there a difference with respect to the average soccer score depending on whether you play soccer yourself? That's the variable plays soccer. And between which categories, if any, is there a difference? So let's see how many we have. 3. I think the first one must have been I play soccer competitively, and the second one is I play soccer but not competitively, and the third one is I do not play soccer at all. So we have 3 groups here and 1 interval scaled variable to compare it with. You could argue actually that this one is not really interval because it's bounded above and below. But if you would go for interval here, I wouldn't mind so much. So interval scaled variable, 3 categories. What do we do? Maneuver might be worth a shot. What was it called? Soccer score. And the other one is play soccer. Don't add an I dot or anything there. We see here that this variable actually has an influence, so there is a difference between these 3 categories. The only thing that we don't know is between which ones. Was that part of the question? Yes. So for that, oh. By the way, I typically outline these kind of things also because it makes it easier to find your own typos if something goes wrong. So let's see, here we get that same result again. There are differences between the different categories, and we see here that the only difference that is significant actually is between 1 and 3. You see that there. Oh, is there another one? Oh yeah, and this one is also below 0.05. Indeed, indeed. So that is the answer to 7A.
Shouldn't we check for humanity first before another?
Yeah, I was actually trying to figure out if I... No. Okay, yeah, the answer is yes. For a minute I thought I do that every once in a while. Run the test, and then later on were we actually allowed to do this? And I thought that that would happen here, but it doesn't. So here we do have to check for normality for all these separate ones, just to see if that is working out. Play soccer 1, 2, 3. Let's have a look first. If this already doesn't work, then there's no need to do the other ones. Oh, okay. So clearly this is violated here, yeah?
Yeah, so only with regression you test the assumptions after you run the test?
No. Normally you always test them before. The only thing is I mistakenly thought that in this question, first of all, in the do file here, I created shorthand versions of the actual question. And I think I thought that in the do file, in the Word file, I typed run your analysis without checking assumptions. Every once in a while I do this, and then asking, okay, was that okay? But then I looked at the questions that followed, and they weren't there. So you should have done here, indeed, what you already said in the beginning. Okay, if you want to run an ANOVA, you need to check your assumptions, and you need to do that first. And it's good that we did it, because the ANOVA itself wasn't allowed, actually. So there's no need to do any more testing here, because we see that normality is violated already. So let's just leave it standing here, but instead try to come up with a transformation. That'll work. Okay. Oh. So here the nice stuff begins. So now you know, yeah, I want to try that ladder command, because that will give me a transformation. And from the list of transformations that might work, I can try to pick one that actually does work. Well, here this is apparently not working. So we have a soccer score if play soccer equal to 1. Now why could that happen? Well, for now, let's just assume it away, and let's see if this also happens for the other ones. Now, there it does work in the sense that we at least do get some output. So the nastiness happens for that first play soccer variable. What might be going on here? Any clue?
There might be not enough cases.
How could we check?
Type soccer score if play soccer is not equal to 1.
Soccer score. Yeah, let's just look at all of them. Yeah, and there we see it. Play soccer equal to 1. Yeah, this will end up with these over there, which is hardly anything to work with. So let's see. Let's back up a little bit and look ahead first for the other two if they worked, because here I have the whole set complete. I can try to figure out something. There I don't. So what must have happened here?
Maybe there's a 0.
I think so. Sorry, that's the wrong one. There are a couple of zeros in there, so any log of this is not going to work. So first, let's try to do something else. And, well, for instance, add 1. Then we have positive numbers here, and we should be good to go. So okay, let's see if this makes things better. Doesn't help so much, not for that first bit, that won't work. Let's get rid of that one. Now try again. Now we do have a full list there, and a full list there, so that still works. And this one we need to get rid of, because there's simply nothing that will allow us to test there, because we do not have enough cases to work with. Now let's see. Cubic would be fine for that second group, and square as well, and identity also, and square root, and the log, and the rest is bad. So everything up to log would be fine, because all these numbers are above 0.05. Second bit, oh, there most of it is bad. The only one that does work is square root. There we have a number that's above 0.05. So we still have that same problem with that place soccer equal to 1. We cannot get rid of that. But what we can do is take the square root, and still it's right on the edge there, but that's certainly better than what we had. So here, the only thing to do would be saying that first one is not going to work, not enough cases in there. The other ones might work, and what I would do here is create that, well, let's say y. Now I have a new variable over there. If you really want to be concise here, you double check that this one now is normal, or at least normal enough, so to speak, because what you see in the letter command output is the results of the SK test, and what we need as well is that swilk test. So now we do this whole thing again for our new variable. Okay, oh, yuck. Still bad over there. Okay, so I'm running out of options here. I cannot really come up with a decent transformation that will solve all the problems here. First of all, I had that problem already with that letter command, so that already is not ideal. And here we see that the only one that did work, in fact, doesn't work if we do that swilk test for normality, because then the second group violates the assumption. Okay, so that would mean there's only one thing to do left. Conclusion here, none of this works. What do we do? Yeah. There we go. Here we have our results. We see the different kinds of rank sums and the test of equality between these different groups, and we see clearly that the test is rejected. So equality between the groups is certainly rejected here. Yeah.
Can you not just say, because you have less than 10 observations, you always will find that it's not normal and test not make it normal with less than 10?
No. No, I mean, just draw 10 cases from a normal distribution, and if you then run the test, you should be perfectly fine. In fact, we did get it right for a group number 1, where we had only 7 in there. So here we see a difference, and it's quite obvious where the difference is between 3 on the one hand and 1 and 2 on the other. But if you are forced to say something about where the differences are, I'm not sure that you will. Let's see. No. I don't think that was in the... yeah, there was. Between which categories, if any, is there a difference? Okay, now you run into the trouble here that Kruskal-Wallis command doesn't allow you to easily test that. So the only way to do it is simply to compare them all by hand, so to speak, by confining that Kruskal-Wallis command to only a restricted set of the categories. So if you want to compare between 1 and 2, this is the way to go about it. And you see here, equality is certainly not rejected. So there is no reason to assume a difference here between 1 and 2. And if I would, let's try one other one. Try to, well, for instance, do this. This is between 2 and 3. And here we do see a significant difference. Bless you. Between 1 and 3 would require a little bit of extra typing. Go like this, and in all likelihood you will find a difference as well, indeed. So the question was, where do you find the differences? Well, between 1 and 3 and between 2 and 3. And again, here you could argue, yeah, it's only 3 tests, but you do more than just a single test. Would have been at least consistent to have some kind of Bonferroni correction here as well, but we don't have it in this command. So this is the only way to go about it. Okay, here I added some trouble myself, because I said here now add the variable soccer guess as a predictor as well. I remember what went wrong here. At some point I mixed up, okay, run the analysis of variance in part A and now continue with that analysis of variance, even though we found out that actually it wasn't the right thing to do, but I didn't write that. So here you were sort of stuck. Add the variable soccer guess as a predictor. Soccer guess is actually a question that was asked to people before the actual quiz. You're going to get 10 questions about soccer. How many do you think you'll have correct? And that's also a number between 0 and 10, of course. So if you would have done an analysis of variance there and you had not seen that this was not allowed, this would actually have been wrong. But that would have allowed you the possibility to continue with analysis of variance in the B question by simply adding a covariate. So a couple things I counted as correct here. So if you would say for this B question, yeah, you're asking me to add a covariate, but yeah, there was no way to do it because we had to refrain from an actual analysis of variance in A. So I cannot add a covariate. I would actually, there weren't so many people who had this, but if you had it, then this would be counted as correct. And if you just did it with an ANOVA, that would also be counted as correct, and I would give you some mental bonus points if you would say, okay, I'm going to do this, but I don't really understand why, because we just saw in A that we actually shouldn't. And in a way, these mental bonus points do deliver something, because that will mean that if in the next question you have an answer that is, you know, not, I find it not really correct, but okay, I add the mental bonus points from the previous question and it's nevertheless correct. Okay, so now add the variable soccer guess. So we're going to do this. So there we have it, the ANOVA table. Now we see that that play soccer variable is no longer statistically significant anymore. So it doesn't matter anymore if you play soccer or not, as soon as you control for the soccer guess that people have made, which makes sense. You know, I asked you before, do you know something about soccer? And that will, in all likelihood, indeed correlate with how many questions you actually have correct. And at that point, as soon as I know that, then knowing that you actually do play soccer doesn't give me any new information anymore. So now that doesn't help anymore. By the way, if you would incorrectly forget the C over here, the C for covariate, then there is one way, at least, in which to pick this up. Here you again see that this soccer guess variable is statistically significant and that this one isn't. But that's no way to pick up on your mistake. But what you also see here is that 10 degrees of freedom are used to estimate this effect. And the 10 comes from that there are 10 different categories. So these 10 different categories are used separately as dummies. If I would type regress here, you would see that. Now we have separate dummies here for each and every value of the soccer guess variable. And that would hopefully show you that what you did here was actually wrong. And you should do it like that. Okay, so you have to explain here first, well, in this case, why you start running the ANOVA, because in A actually we found that we shouldn't. Then you could say something about that you want to include this as an interval scaled variable. If you have strong arguments not to do this and include it as separate dummies, fine as well, but then, you know, make the argument and do it. And then it would be nice to say something about exactly this finding that we have here. The fact that the original play soccer variable now disappears. So there's also something to learn from the subsequent use of different models where one is a subset of the other. You see here, first play soccer was in there and it did something. As soon as I control for what you think you know about soccer to begin with, then we see that the play soccer variable plays no role anymore. Any questions up to here? Don't take the do file as it is now. I'll put it online, but don't take it as that this should be the answer, because you need a little bit of text before the actual answer that I have here, explaining why you choose the command that you do. And you need a little bit of text afterwards, what the actual answer is, and how you deduce what the answer is from the actual output. Yeah.
Could you take one of the questions and put the text there? Not for all 8 of them, but maybe for one of them?
Yeah, sure. Name one.
Yeah. Doesn't matter so much as long as it's not 1 or 2 or something.
Yeah, I mean, for the first one, if I ask you how many cases are there, then I don't need a novel for the answer is 102. But let's see. So let's take 7a. Is there a difference with respect to the average soccer score? Blah, blah, blah. Can I say it out loud? I'm getting cramps in my hands from typing like this. So the first thing you want to say here is soccer score. I take soccer score to be an interval variable. Or I don't take it to be an interval variable because I know it is confined between 0 and 10. And because of that, I will first transform it. That would actually be the better option. But here I would be okay with the fact that you say, I take this to be an interval variable. And why? Because the difference between two values is well defined across the whole range of the variable. So we're good to go here. And what was it again? We have 3 categories here. So we are comparing an interval scaled variable across 3 categories. So I'm going to use, in principle, ANOVA, if the assumptions allow me to. First, I'll test the assumptions, normality for each category. Okay, then you do it. Then you see pretty fast here, after you do it, okay, I see that for the second and the third category, normality is violated. And you know, what people do typically is a highlight, for instance, where I can see that it is violated. So what I do next is I try to come up with a transformation of the interval scale variable. For that I use the ladder command. Okay, you try it, and then in this case, what happened again? Yeah, I see first that it doesn't work for that first category. Even there you could argue it must have something to do with the fact that there are not so many cases there, because this is what Stata is telling me, but I'm not really sure about exactly what is happening there. I continue for group number 2 and 3. You can start to feel why I didn't want to type this all at this moment. Now I have to remember what came. I see that soccer score has zeros in there. That doesn't allow transformations. So I add 1 or 2 to the variable. Okay, then I'm looking for a transformation that works across all groups. Square root is the only one that gives values above 0.05 in all 2 groups that I can test. I double check with the swilk command that indeed across all the 3 groups we now have normality. The answer is no, because in the second group it's not working. That leaves me only one thing to do, and that is that Kroskal-Wallis command. Kroskal-Wallis command first shows that there are differences between groups, but not between which ones. Again, you could pinpoint the number that you're looking at. To compare the different groups, I run that Kroskal-Wallis command on sets of 2 out of the 3. And then you, by that time, if you have all the previous ones correct in the sense that you correctly tell me where you are looking, then at that point I start to believe that you know where to look. So then it doesn't matter so much anymore. But and then you conclude. I forgot what where the differences were between 1 and 3 and 2 and 3, I think, and not between 1 and 2. So that's what you should write there. And what you don't want to have is, for instance, just the command, and then there is a difference between 1 and 3 and 2 and 3, but not between 1 and 2. That's actually correct, but you could guess it quite easily actually from just looking at the data itself without knowing anything about the underlying statistics. Yeah, in these cases, when in doubt, I have to say that this is actually not correct. I'll give you some points for knowing the right command if you put it there, but then nothing for the explanation that should be there. Anything else? If not, then the schedule for next week is, oh yeah, there was it half a hand?
Plots.
Oh yeah, sure, yeah.
You do the regression and you want to improve it.
Yeah. So this is a totally different question, actually, from anything that was in here. Question number 8, that I'll do on Wednesday because it will take too long. I won't be able to finish that in 9 minutes. And let's come up with a example regression of, well, it doesn't matter what actually. Regress. Okay, so I'm just taking something here. So I'm running a regression here, trying to predict that soccer score again from the guess that's working and from female. So apparently female score lower here on the soccer quiz. And now there are a couple of plots that you can use to stare at. This is one. RVF for residual versus fitted. Okay, the first question is, of course, what is on the axis here? So we have predicted values or fitted values on the horizontal axis. And we can get, as soon as we run a model, we can get a predicted value for each and every case in our data, and we hope that the predicted values are close to the actual ones. And on the vertical axis, we see how much we miss. So we hope that we are close to 0, close to the horizontal line, somewhat halfway. And well, there are a couple of things that we can see here. We came up with these kinds of plots when checking assumptions. For this one, linearity is typically a good example. So if you would have seen what we now don't see, that the cloud of dots would be something like this, starting from below and then going up and then down again, that is typically suggesting, well, there is some kind of consistency in the way in which we miss the actual values here, and that shouldn't be the case. So this is violating linearity. Here, actually, we're not so bad in terms of linearity. You know, all of this is eyeballing plots, and something else that might be of use is, well, this looks like a weird case, perhaps this one also, but certainly that one. So looking for outliers might be an idea here. If you do not, in the end, change the model through transformations, because then the whole story starts again, but stick to the model over here, then at least that point over there is way different from the rest. So suggestive of the fact that you should be able to find an actual outlier over here. And that's all that I would do with this graph. And then still it's complicated because you have to judge this. Is this more or less a straight line or not? And very often it's not so obvious if that really is the case. So that's the residual versus fitted. And it is a V plot for added variable plots. There what happened was, yeah, normally if you would have just one X and one Y, you could look at a scatter plot already to get an idea about the shape of the effect that you're supposed to find here. If you have more than one predictor variable, then this is not so obvious because there's another one in there. So unless you're good at looking at 3D plots, which I don't think helps very much, what you could try to do is you first estimate the model y equal to, and then these two x's. If I'm interested in the first x, I take the estimated coefficient and the x, and I put it on the left side of the equation, and this is now my new y. Now I have a new y over here and only one x over there. And I can look at the plot for that first x, and if I have two predictor variables, as I have here, for the other way around. So now I put that first x on the left, and I look at what happens with the second x that I have left. So you get as many plots as you have predictor variables. And these are all suggestive of, well, if I want to model the effect of, in this case, soccer guess, is a linear estimate a good idea, or might it be useful to come up with something, a square root or a parabola of some kind? And again, only in rare cases it is blatantly obvious what you should do here. So very often you look at this and say, lots of dots, but I'm not so sure if there is anything better. For instance, here, yeah, this looks quite decent to me, but if it would have been better to have something, let's say, going up like that and then perhaps like this a bit, I don't know. So it's not so clear here. And in fact, for predictor variables like the one you have here, a dummy variable, there it's totally unclear what you should expect here. What you see here is, well, these are the ones and these are the zeros. And they are not exactly vertical, and this is because the other predictor variable has been taken to the other side of the equation. And so you see here, yeah, there is nothing much to do with female. If you transform that, if you square it or take the square root, it's still the same variable. So this one doesn't help so much. Again, what it does help you to see is that there might be outliers there. Again, one over there. I think if you would look closer, then that one is very likely to be the same one that we saw in the residual versus fitted plot. And perhaps this one, and it might very well be that this one and that one is indeed actually the same case. So again, some idea here that it might be a good idea to look for at least one outlier. In this case, it doesn't help us very much to try to come up with a different transformation of our predictor variables. And the linearity assumption that we had in the residual versus fitted plot, about that I would say, yeah, that looked pretty decent, with the exception of that single outlier again. Yeah.
Is OV test even useful in the sense that you have so many variables that you could include in the questionnaire?
Yeah, so, yeah. The OV test is useful as soon as you have decided on, let's say, the definitive set of predictor variables that you're actually going to use. Then it certainly is very useful. It doesn't help you at all in trying to find out of the 60 variables or so that you could use, which of the 60 you should use. So that, the word is a bit misleading, omitted variable, as if it helps you trying to find the ones that are omitted, and that it doesn't do. But as soon as you have decided, okay, this is the set of variables that I go for, then you have to check which of these need transformations, and for that, having a stopping rule is a good idea.